Good evening, guys and girls. Welcome to this session. This is about running machine learning models on Microsoft Azure. And the prerequisites for this session would be that everyone who is attending this session is expected to be comfortable with basics of Python. They understand how to run basic machine learning models on, let's say, APIs, libraries like scikit-learn, but they haven't done it on Microsoft Azure. So the intent is that if you know how to do it on your local machine, how would you do on cloud? Also, the agenda would be to explain you what are the advantages of doing it on the cloud and how can you handle big data loads without worrying about the storage or the RAM requirements or the cores requirement on the cloud. So without worrying about the compute, how could you comfortably do things? And most of the companies currently move their workload to some clouds, whether Google or Microsoft, and it's a mandatory skill for a data scientist to be very comfortable with any machine learning services or operations which are offered on cloud. So that's the agenda for the session. If you have any questions, feel free to ask in between. If we have a dedicated kind of a stop, you can always ask me to wait and or raise your hand or let's say ask a question in between. Or if it's not very pressing question, you can just text me and after every like 10-15 minutes, I'll keep checking my chats and I will reply. I hope this works for everyone. Is that okay, class? You may say something, that's okay. Class, you may speak in between. I'm asking you, is the agenda clear with everyone?
Yep.
Yes, that is great. That is great. I want it to be interactive. Feel free to ask in between and we will most of the times understand what we are doing. I do not want you to feel bored at some point of time, leave the session thinking that I do not understand what's going on. Okay, stop me then and there and I'm completely okay with that. Okay, so once again, as I mentioned, the session is on how to create or build machine learning models on Microsoft Azure. The assumption is that you are comfortable with basics of Python and machine learning and you are doing it on your local machines, but you want to understand how to do it on the cloud. Those who haven't done it on the local machine or those who are not at all comfortable with machine learning, they would also not feel lost, but at times they would not know a few things which are not important in the context of working on Azure, but they are important in the context of how to do work on scikit-learn library. So those questions will be answered in my previous session. So they need to, after this session, they may visit the previous sessions which are there on YouTube, which Paras was talking about, and they will have their answers. Is that okay? Okay. Yes. Great. So let's start. So about me, I've been working in data science from past 5+ years as an instructor of data science, and I have taken several sessions across geographies. Apart from that, I have like 10+ years of IT industry experience. I've worked as a Java developer before getting into data science. So I understand data science, big data loads, cloud services, all these, and I've been training, let's say imparting training in in this domain from quite some time now. Okay, just to give a quick review of what we are dealing with for those. So tell me, are there people in this session who do not have an idea about what is machine learning or what is data science at all? Are there any such people in the group today? Feel free to text or speak in between.
Hi Avinash, this is Karthik here.
Yes, Karthik.
But I'm not completely unaware of it, but I'm someone who is very new to this field, so machine learning and data science. So I started learning now. I'm a very beginner.
It's okay. Beginner is okay. At least you'll have idea and things will not be jargons for you. And expertise is not expected for this session.
Okay, then fine.
Only expectation is that you are aware of few things and you have seen or at times done with assistance some things on the local machine, and now you want to understand how can I do it on the cloud, because most of the companies have their data loads on the cloud. They do not keep it on premise, they keep it on the cloud because they're dealing with big data loads. So there are various reasons why they're dealing with data sets which cannot be stored on one machine, a single machine. So let's say I'm dealing with like 50 TBs of data. So I want it to be stored in a distributed environment, and I prefer the cloud because cloud at the backend is taking care of distribution of my data loads and making me feel as if I'm working on a single standalone machine. Okay, so most of the organization they keep their data on the cloud, and this session is about making you comfortable with the cloud. You say that you are a newbie and you have some experience with data science, which is okay because most of the things are more or less the same, whether you learn it on do it on the local or on the let's say on the cloud. Most of the steps are same. There are a few steps which are different, which I'll be taking you through, revising and telling you that this is the difference. Other things you are anyways going to learn. The session is not expecting any expertise in data science, and we are not delving into the finer details of data science, either the mathematics or anyway not intricate details. So I believe that is okay. Okay, Karthik?
Yeah, Anish, thank you. Yeah, that's
Great.
clear.
Avinash, Sanjay here. I have a quick question. Like as you mentioned, like you were a Java developer, so
Mhm.
just wanted to know like how you transitioned into data science, like what path you choose,
That's
what
a
path.
nice question. Okay, so I don't know how it happened. I would say I was destined to be in data science, but if I look back, I can always tell you a story which makes sense right now, but did not make sense when I tried to do it. So the way it happened was I was working as a Java developer, and then I was working for a company who used to create mobile apps, and because we were serving to a lot of applications, mobile apps, we thought of analyzing that data, and that was back in 2012-13. So around that time, Spark was new. Spark came out in 2011, and we thought of using Spark. So my manager asked me to learn Scala and start working on Spark, and that's how it all started. So I used the Spark ML to do some analysis, and what I realized was, although I can do a lot of analysis, and I know at a high level that some algorithm is giving me these kind of results, which makes sense, but I did not know how these algorithms worked. So after that work, I chose to quit my job, get into study. I studied data science for a year, a regular classroom without any work, and then got a job in data science. I was very interested in learning the maths and understanding the algorithms in much detail than just the engineering part. And engineering was anyways easy for me because I came from a development background. So I quickly picked up languages like R and Python, apart from Java and Scala, which I already knew. And that's how it started. So now it has been like 5+ years, and I have been teaching people, helping them transition their field. But yeah, that's how it started for me. And it could be different for each one of us. As long as we are willing to learn and we are willing to devote time, I don't think it's anyway tough. It's easy. It's not super easy. It requires time and devotion. But if you are interested, it's easy for you. Okay.
Yep, thanks for answering.
Most welcome. So now let's understand. So machine learning at a very, very high level, it's different from software engineering in a way that in software engineering, we have a specific set of steps, which we know if we follow in a desired fashion, we'll get a expected output. Machine learning is different is in a way is that I cannot say that this input will always lead to this output. Okay, and that's where intelligence comes in. Intelligence comes in. So a software program is not an intelligent program. What it will do is, I always know if this is the input, this should be the output. So the program acts like a function. I pass a value of x to a function fx, and I always know that fx will lead to a specific output. That's what a program does. Takes some input and creates some output. When it comes to data science, it takes some input and then incorporates some intelligence on that input. Now, how that intelligence is incorporated on that input and then the output is decided is something which we study in the field of data science, is something which machine learning algorithms do all the time. Okay, and how do they do it is, let's say we'll take one or two algorithms today and we'll see how they are doing it in a very, very high level detail, not great mathematical intensity. But the second part is, once you know that these algorithms do these things, how do you do the engineering part, as in how can you apply those algorithms and solve real life business problems. So once I know that there is an engine which can drive a car, you take this example. So once I know that there is an algorithm which can solve certain problems and lead to intelligent solutions, once I know it is there, one way is that I get into the details of all the maths, which in the case of car will be understanding how the engine works and everything about that engine. But the other part which we definitely use a car a lot is to drive the car, to apply those algorithms to solve real business problems. So the second thing which we'll be doing is applying all these algorithms to solve business problems. And that's what mostly data scientists do, or machine learning engineers do that. Okay, so that's the focus of this session, that if I know that some algorithm leads to a particular output, how can I apply that algorithm and solve a problem? Not always knowing the details of the algorithm, not always knowing the details of the engine, but we want to learn how to drive a car. And for that, we do not need to know how does the engine work. Is that point clear to everyone? Class? Does that
Yes.
make sense? Yeah. So yes, there are some complexities, and the complexities are there all the time. So it's like, if I want to learn how to drive a car, I know that the engine is complex. I do not know how the brakes work. Means not very detailed. I have some fair idea that if I press this lever, the car will stop. I do not know how. Okay, but I can still fairly learn and become a good driver. I do not need to know the engine details all the time. So in order to become a good machine learning engineer or an applied data scientist, you do not need to know all the times that how algorithms are working. Although there are other roles also, there are research scientists also, and I also work in research a lot. So which means I always experiment with new algorithms and propose algorithms in the market. So that means you have more deeper knowledge. But then that part and this part is together building up the industry of data science. Okay, it's very, both the parts are very important in the domain. Okay, so let's focus on this. Now today's session is centered around it. Okay, you know how to apply certain algorithms and solve business problems. How would you do it on cloud, on Microsoft Azure? So that's the topic today. Let's understand it and stop me wherever there is some glitch, or if you think that this part, if I could explain before going ahead. Okay, so what are the basic tasks? I'll just do a quick revision of the basic tasks in data science. So the basic tasks in data science would be in this pipeline. If you look at the pipeline, the machine learning pipeline, you would realize that there are a few steps which you often need to do in the pipeline. And that is about data collection. That is, you get the data. So at times the data could be crawled from various websites. At times you import the data or export the data from various databases. At times the data could be on some distributed systems like on Hadoop or some cloud. So you have to, at the end of the day, wherever the data is, you have to bring it so that you can apply algorithms on it. So first step is collecting the data, making several pipelines so that data is ingested. If we are working on a big data atmosphere, like we're working on the cloud, so let's say data collection would be putting all the data on cloud, Microsoft Azure cloud. If I'm working on my local machine, for me data collection would be, let's say, importing data from various databases on my onto my local machine, or my program making such calls to databases. So that's the data collection step. Then comes, so once the data is there, the step is to clean the data. Why do we need to clean the data? Because these machine learning algorithms, although they are supposed to behave in an intelligent way, but again, they are at the end of the day software codes. So they are not super intelligent like humans. The level of intelligence is not comparable to intelligence, although it's growing very fast. Okay, so you need to provide the data in a specific format for algorithms to work on it, and that format, although might be different for different algorithms, but there is one commonality, and that common part is that the data should be clean. That is, it should not have missing values, it should not have nans and nulls. Some of you might be aware of what is a null or what is a nan value. Sometimes if there is a blank in a structured data set and there is no value present, then it is the database will identify it as nans. I mean that cell itself is not applicable, or it's not a number, or there is null. So null doesn't even mean zero. Null doesn't mean zero. Zero could be a valid value, but a null may mean something which has not been specified, or no value has been given to that object at all. So we need to take care of it in an intelligent way. Sometimes we remove those null values. Sometimes we impute those null values by 0 if it makes sense. If it makes sense to me, let's say I'm talking about some production data, and for a month, because of COVID-19 pandemic, production did not happen. If the production did not happen, the data field for that month in the production would be null because there was no production. Now, for my analysis, I'm looking at the production per month, and for this month the production did not happen. I can choose to keep 0 there. For me, the production did not happen because what I'm doing is, let's say I'm doing a job like how much did the production happen compared to the planned production. Let's say every month there was a plan and there was some production. So for this particular month there was no plan and no production happened, so I can impute 0 values here. Okay, so I can keep the amount of production. Sometimes it makes sense to, let's say I'm doing a time series forecast and I realize that okay, some months production did not happen. So what I can do is I can impute the value for production, maybe by the mean value of the average production per month, because I'm building some type of machine learning model to which I want to tell that okay, whatever was the production, there was average level of production was there even in the months of pandemic, just to ensure that I get the right data to build a forecasting model. So intelligently I will decide what to do, but one thing is for sure, I have to clean the data. That means I cannot keep null records. I cannot keep a data set which is, let's say if I would need a structured data, I cannot have like different sizes of row. So if I know that every row has 10 columns, so each of the row in the data set should have 10 columns. None of the columns should be blank or nulls. If they are, then I have to make a decision whether to remove that column or whether to impute some appropriate values. The appropriate values could be sometimes 0. The appropriate values could be sometimes the average or the arithmetic mean. At times it could also be a model based imputation, which we'll talk about later. But we can always impute such values or remove such rows completely from the data, and that particular step is called data cleaning. Once the cleaning is done, you extract various features from the data. So feature extraction is again important. Let's say there is a field called date of birth, and this is a bank record. Okay, and there is a field called date of birth. Now this date of birth field may have date of birth for each of the customer, and it may not be very sensible for the machine learning algorithm to get anything from this date of birth to give any value to my analysis based on the date of birth. But if I change the date of birth, if I subtract it from current system date, what I will get is the age of the person, and maybe it is important for my analysis. Let's say the bank, this is bank data, and let's say I want to make a decision on approving or disapproving a loan. So if I do that and change this attribute, then I can, if I change this attribute, then I convert this date of birth into age, which is a derived attribute or a feature which I have extracted for my use. And this age of a 25 years person or a 35 years person may tell me something, that usually 25 years they default more on loans versus 35 years they, if that is present in the past data. So for me, learning could become easy. Sometimes there are other complex things. I gave a very easy example, but sometimes there are complexities of feature extraction. Sometimes my particular algorithm may want the feature to be in a certain, follow a certain distribution, and it may not be following a distribution. And I do some power transforms. I at times take log of that feature, or maybe a box-Cox transform, or any other power transform, some exponential transform, to bring the feature to the distribution I'm looking into. So that, and that is something which, that's again means it's part of creating new features for our purpose. Sometimes I have a first name and a last name together in one field as name, and maybe I am looking for two different fields here, so I can create two fields out of it. So there are various things. Each of these steps are after cleaning. Once I know there is no null, I extract those features which make sense. Sometimes if there is a field like a ID and it is not useful, I completely remove it from the data. All this happens at feature extraction. Once you have the clean data and you have extracted the right features, you apply machine learning algorithms on it, and that's called model training. You train a model, and that model could do anything. It could tell you how much, let's say what is the amount of loan a person might be suitable for, means how, what is the maximum amount of loan this person could be approved. So that's a regression kind of task, and I can say that okay, if Avinash has applied for a loan, a personal loan, maybe you cannot give him a loan for more than 5 lakhs. Okay, that's his that's what he can comfortably pay to the bank. So that's the maximum amount. So that's kind of a regression kind of decision, how much amount can be approved. Or another decision could be depending on the algorithm. It's a classification algorithm. The decision could be whether he or she should be approved a loan or not. So should the loan be denied for this customer or approved, depending on how his past attributes behave, like what is his income, what is his let's say age, what is his credit limit, how has he behaved on the past loans. And based on these past data, we find an expectation how will he behave on his future loan. And that's how the algorithm helps us create a model which will make the decision of whether to approve or disapprove. This decision will not always be correct. It's not a software program which is always going to give you the right results. This decision will have a degree of correctness. So I can say that if my degree of correctness for this classification is 90% accuracy, that means I'll be accurate 90% of times, and 10% of times I could falter, which is okay, because if I'm not using this artificial intelligent algorithm, and humans are making decision based on the past experience which a manager usually does for approving or disapproving a loan, the accuracy is, let's say, 60% or 70%. So once I find out that okay, the base level, this is the accuracy, if I can use the AI algorithm and improve the accuracy, and the improvement is 10% or 15%, then I can put this AI model which would also automate the job, simplify the solutions, and lead to better results. So definitely data science is useful. How it is doing that? So usually when a person takes a decision, that person is taking a decision based on his or her past experience. So if I am a person who is supposed to approve or disapprove a loan, I'm working as a loan manager from past 15 years. Every day I deal with several customers, and based on that I have my experience built on it. Okay, this kind of customer with this credit limit and this income, it's okay to give the loan. Okay, for this customer it is not okay to give the loan, although there is a part of hunch involved, and there is also a lot of analysis, like fetching the credit limit from the website, seeing the past bank statements for the customer, seeing his salary and all that. So there are a lot of things combined with the hunch, and the manager takes a decision. Now the decision is not every time correct. So bank also has losses, people are approved loan and then they do not pay it back. So if an AI model takes the same past data and give better decisions, so that whenever the person has been approved a loan, the model can find out, no, this approval was not correct. We would have known in advance that this person would not pay and we should not have approved the loan, or the loan amount should have been only this much. So we can always compare with the past data, and if we see that a machine learning model or an AI based solution is working better than what the bank employees have been doing, then obviously their work could all comfortably be, uh, let's say, this model can handle that work. And also the only reason why it does it, because it will not only look at the experience of one bank manager, but the AI model can simultaneously look at the experience of all the bank managers across all the geographies, look at various records, and then capture all the experience of all the managers and then take a decision, which is better than the decision made by one person and his experience. If you get my point, class. Do you understand? Just don't get into how we do it, because I'll take it with an example, but that is exactly what is done in machine learning. Is that point clear?
Yes.
Clear.
Yes. Okay. So we'll take it with an example how it is done. Once you have trained the model is built. You want to evaluate the model, how good your model is doing in terms of accuracy, how good it is doing. If it is a regression kind of model, so let's say if a person deserves a loan of 5 lakhs, and your model says okay, 4,98,000 is okay, so that means you are 2,000 off the course. So in terms of regression, in terms of predicting a number, what you do is you find the mean squared error. How what is the error in your prediction? How far away are you from the correct prediction? How can you find that out? Because you have the past data, you know what was correct. You already know what was correct. You want to know, based on your prediction, how far away, either more or less than the desired output, were you. Okay, so you can do both regression, classification, and these are just supervised learning algorithms. There are other types of algorithms which will come in data science. Algorithms like creating a good clustering algorithm, where I'm forming a cluster. I do not have a past data or some intent in mind. I'm trying to detect the inherent patterns in the data, and based on those patterns, I'm grouping them in various clusters. So those kind of algorithms are called unsupervised algorithms. And I'm giving a very quick summary, but that is all is happening in machine learning. So I have a bunch of unsupervised algorithms, a lot of them in fact, and a bunch of supervised algorithms, which include regression and classification. And data science models are helping me solve these problems by creating models on the past data. And if the models are working, then what we have been doing without those models, if the evaluation of that model supersedes any of the past work which we have done, then these models are deployed in production and they are used. Okay, so that's the complete pipeline, and this is why it is and then the model starts serving. So that means that you start using the model. Okay, now let me.
So, Avinash, the least mean square error, like we have this only for linear regression, right? Only for this.
Very good question. So any kind of learning algorithm, linear regression is one of the algorithm which does the regression for you. I'll quickly share another screen, but there are other algorithms. So apart from linear regression, you also have the let's say random forest regression, you have decision tree regression, you have support vector regression, you have regression models in k nearest neighbors. So there are a bunch of algorithms and they can do both the tasks. Most of the models, they can do both of the tasks. So a regression algorithm can do can predict a numeric value and we call it linear regression. When a regression model helps me do a classification, I call it logistic regression. Similarly, a tree-based model can help me classify which class, whether someone should be approved a loan or not, and also it can help me regress the same model. Although the uh, underlying structure of a tree model is very different from a regression model, and for a support vector it is entirely different. For a k nearest neighbor it is very different. For a Bayesian-based model it is again different. So different models have different mathematics underneath, but all these supervised models can do both for you, can do regression as well as classification. So anytime I'm doing a regression, whether it's linear regression or support vector regression or a tree based regression, I look for attributes like mean squared error, adjusted R squared, means anything which has to do with finding error in the numeric prediction. Does that make sense?
Yes.
Okay, so let me just share something quickly and then we'll move on to because the intent is Azure, so let's move on to Azure after that. Let me. Okay, let's look at this. First I'll show you a file and then I will run this on Azure. I'll tell you how to run it on Azure and everything. Okay, so this is a regular file.
I
I'm
think
sorry.
the screen is not showing up.
Yes, I'm just doing that. Give me a sec. 1 sec. Yes, is it visible now?
Yeah, it's visible. And isn't the comment section available to pass in some comments?
Pass on some comments where? On the Teams?
On the Teams, yeah.
Yeah, you can write the comments on Teams and you can also interrupt in between and ask me the questions right away.
No, but I would prefer putting the message, but I don't see an option on the Teams here to put in the message.
Give me a sec. Paras, can you help us with that?
I'll be here. I'll just show you how you can send a text message. Hold on. I'll just show you. I'll share my screen for a moment. All right.
Yes, please. I'll stop the sharing. You do.
So if you open Microsoft Teams, you should see this little bar at the bottom.
Yes.
If you click over here, it will just show you the conversation. And if you just click
We are
on
not
it
able
again,
to
it
see
will
that.
We are not able to see that message option in the bar in the down.
Yes, we don't have any option on the
Oh,
screen.
And,
We don't have
there
this
is,
icon.
and there is no hand raise also.
No, we
okay.
have. I have a
I'll-
hand raise option, but not a chat option.
Okay, maybe we can continue the session while I fix that in the
Okay.
in the back end. I'll have to change some roles. You can
Okay, that
continue
sounds
with the
good.
session. I'll just fix it.
Okay, thank you.
Thank you, Paras. Okay, let me just share my screen now. So where are we? Okay. No. Okay, now on this data set, what we are doing is this will be run on local first, on my local machine, on my Jupyter handle, and then I'll show you how to do it on Microsoft Azure. Okay, not many differences. A few lines will be different. For this, I believe not much difference. For the second machine learning, there will be some differences, and I'll show you, and I'll tell you why the difference is not there. Okay, so let's look at the data. This file is mostly about cleaning and manipulating the data files, and this cleaning and manipulation class has already been done on the local, where I've explained this file and it's available on YouTube. Okay, the intent is how to do it on Azure, but let me just take a quick look through the file so you understand what is happening in this file. So in this file, we have imported the pandas library, the scikit-learns, load iris. Iris is a data set in scikit-learn, very famous data set for various types of plant leaves. We'll just look at the data and we'll understand it. Okay, so we load the data, load iris, and then we create a data frame out of it. Okay, let's check this. And this is loading. This asterisk signs means it is loading, and once it works, we'll see it.
I have made all of you a presenter, so I think you might see the option to use the chat now. If you don't, maybe just try reconnecting to the meeting.
Okay, we'll try that. Thanks.
Thank you, Baras. Okay, so now that we have read the data, we can see the information on the, or let me just run the files together in one go. Restart and clear all outputs. So all outputs are removed, and let me just run the file. And we'll keep working on this. And I'll tell you the differences when we put it on Azure. But at the moment, all we have done is we have read this load iris, which is a data frame, a data set available in scikit-learn. Okay. We have seen the information on the data, and we see there are four columns, total 4 columns, sepal length. Can you all see my screen, or shall I make it bigger? Is the font okay?
That's
Is
fine.
it better? It's better? Okay. So yes. So we simply loaded the iris data set, and in this data set, what we are doing is we are looking into the information of this data. This info command helps me look at the information of this data. I see what is there in the data. There are 4 columns, 4 data columns named sepal length, sepal width, petal length, and petal width. All these things are in centimeters. There are total 150 records, and all 150 are non-null and of type float 64, which is the data type. That means these records are not null. There are some numbers, and the numbers are float. That means they will be decimals. Okay, let me look at the head of the data, df.head, and we indeed see there are 4 columns. Each of the column there are some numbers which are float type. That means they have decimal values. Okay, so we have looked at this. We can look at the tail of the data, which is from the last end, and we see we have 0 to 459, starting from index 0 till 149. That means total 150 records. And dealing with missing data, which is not there in this case because there is no missing data. But let's say if, for those who are comfortable with NumPy, if you have a missing data record, let's say you create an array of a NumPy object 2 none 6 8, so none is missing, and you can always impute this none with some other value, or you have these missing values. You can also find out np.nans, and if you do a 1 or a 0, you'll get, I mean, if it's not a number, you will always any operation you do, you get not a number, which is nan. Apart from that, you look at other details in comparison. Let's say you are finding the max and everything, and it says nan, because nan is the maximum number here. So you have to understand that if there are nans, your analysis will not be correct. okay, and you would want to impute it or remove it or do few things about it, okay. And in this file it has been these commands are talked about, which helps you learn. Is null is one of the common commands we use. Is null, not null. Drop na is again which we do not use for finding whether it's null or not, but what we are doing is if there is null, then remove the entire row, or maybe if we change the axis, then remove the entire column. And fill na is what we are saying is if there is null, just replace that null value with something like a 0 or the arithmetic mean or something what we decide, or maybe from some function just replace it. So these are the four things which are very common. And sometimes we use is null or is na dot sum, which means I want to find out how many records were null. Okay, so these are common things which you usually use or for analyzing data sets. So let's say if this is a series, panda series, I can say is null, and what is null tells me is for every index, like for 0 index, no, null is false. For the first index np.nan, yes, this is null, so it is true. Third, again it is null, it is not null, it is blank, so it is false. And fourth, it is none, so none is also true. So none and np.nan, these are nulls, okay. Whereas this blank is also not a null, it is like a blank space, and blank space is not null, okay. So you do this, you find out there are dropping some. So let's say I say example3 dot drop na, that means I have dropped the values where there was null, okay. And once we have dropped, then we don't have anything left. If we have a 2D let's say data frame, pandas data frame, and I have a null here and a null here, so that means I have a null in the first row, second column, and in the third row, first column. So index wise, if you see, I have a nan at 0 1, index 0 and index 1, and here at 2 and 0, row 2 and index 0, okay. Now what all can we do? If I do a drop na, I am only left with index 1. Why? Because drop na by default takes axis. There's a keyword called axis here. It takes by default axis is equal to 0. Whether you write it or not, that is the default, which is it has taken. So what it does is in the row axis you have a null here and you have a null here, both these, because I've done a drop any. If there is any null, just drop that row completely. So I'm only left with the row with index 1, okay, and this is the row we are left with. And if I change axis equal to columns, that means I'm looking at column wise. In that case, this column has a null, this column has a null, only index 2 column does not have null. So axis 0 or axis row or axis 1, also called axis columns, which I can do. And if I specify columns, then only index 2 column is remaining. Both these columns are dropped, okay. So that's very common use of, let's say if we have a null value, how do we deal with it? Most of the times we want to remove that value for analysis, but again it depends. I have 10,000 records and I have like 30 null values. I can remove those 30 rows and keep the 9,970 columns for analysis. But if I have less records, I cannot simply remove them, so I may try to impute or do few things about it, and we'll see. That's more into which algorithm I'm using and what kind of analysis I'm performing. But these are the commands which I will be using. So we've written np.nan and we can find out the nans, and then drop na axis equal to row. This is a default axis. Axis row is default. Threshold 3. What does this mean? That I will keep it only if at least 3 of the items are not null. So here we have 3 of the items not null, so it is kept. So that is 3. If only 2 items are not null, then I will remove that. It will be dropped, okay. So, and there are various, this is also a parameter, like threshold is a parameter, and this is all about if you go to drop na command. So if you, let's say, go to this pandas drop na, and then if you look at all the details of drop na, so you will find out all these features which you can always do. So you know, this is the axis, there is how, there is threshold, there is subset, there is in place. So always when you are new to it, you go to this page, you see what all features are there and what each one of them does, okay. By default it is any, which means if I did not specify anything, then it will remove the entire row or the entire column. Axis by default is 0, or also called the row axis, okay. Threshold by default is, so you do not have to specify, but if you do not specify anything, even if there is any single value, it will remove. But if you specify a threshold, it will look, if these many are not nulls, then it will not remove, okay. And simply subset and in place, you can go about and read any of these functions in detail while you are working on it. But these are the pandas functionality and the numpy functions are sufficient to do data cleaning. Okay. Then there is a fill na. Fill na, and this is a method forward fill. So what does it say? Let's say these are my records, and I'm saying is do a forward fill. So what I'm doing is I'm filling this value here. Okay, this is fill na 0, so I'm filling in place of b. If you look at example 5, the b part was nan and the d index was nan. So at the b index here I filled 0 and d index also 0. So anything na I filled 0, but I haven't changed example. If I write at example 5 equal to example 5 dot fill na is 0, then this dataset changes. So I have done this example dot 5 dot fill na, but if you look at here and I do example 5 again, you would realize that it has not actually modified the actual array. So it is still nan. It's just that this thing is modified. If I save it in something like x, then that x is modified. If you understand my point, class. Is this clear?
Yes,
Class?
Avinash.
Right. So it will not modify unless and until you do example 5 equal to. If I write something like this, example 5 equal to example 5 dot fill na, then it will make the changes. Right now it will show me what is example 5 dot fill na, how will it look like, but the changes are not saved back into example 5. Okay, so you can see example 5 is still the same. Okay, now as I know that example 5 is still the same, I can also do other things on example 5. Example 5 dot fill na method is equal to forward fill. So I know in example 5 I have b and d as nans. I'm doing a forward fill. So if there is any na, that means b or d, then it will fill the value forward. So here this 1 will come here and this 2 will come here. Forward, I'll see if there is a nan, I'll fill the previous value. So I do a forward.
Hello.
I fill here 1 and I fill here 2.
Hello. एक minute रुको.
Okay. So please mute your mic. So again, then there is a backward fill. When we talk about backward fill, it fills it backwards. So I had a NA on B and D. Now it is filling backwards, so it will look at C, and if there is any NA before it, it will fill it. Here E was 3 and D was NA, so it will fill the value of D from E. So this filling happens
Hello?
backwards. That filling happens forward. Okay. So now these are few methods, and again, this class is not about teaching those methods, but whatever is on the file, you should understand that. And there are various methods here. Okay, there could be various methods. There could be customized codes in which you define how do you want to fill these NA values. But pandas and numpy make it very simple for us to do. Sometimes you can fill it by the mean. So it is saying that whatever are the NA values, you fill with the mean of these values. So let's say I have a 1, I have a 5.5, I have a 7. I take out a mean of these values, and whatever is the mean, I fill in the 3. So I can have 7.5, 12.5, and 13.5, and then I can fill that mean here. So all I have to write is this one, example 4.mean. Okay, and removing duplicate data if the records are duplicate. So here, if you see, leave the index number, but this record is A1, B2, A1, B3, B3. So I have B3 and B3 twice. B2 is unique, A1 and A1 twice. So one A1 should be removed and one B3 should be removed. So all I'm doing is example 6 dot duplicated, and I see that there are 2 true. Here there is a duplicate, and here the last one is considered a duplicate. So this is a duplicate and this is a duplicate. The first one which I found is not the duplicate. And then when I say drop duplicates, it will drop those. So 0, 1, 3 is remaining. The 2 part is dropped, which was a duplicate, and the 4 is dropped. And similarly, we do a lot of cleaning. We can do joins. We have a data frame, this employee data frame, there's a group, and I want to join this data frame. Employee hire date is there, and I want to merge this data frame 1 and data frame 2. So I've merged this data frame. So for each employee, depending on the group and the hire date, now all the 3 information are merged into one table. We can do a many-to-one join, which means group, one person may have, 2 people may have one supervisor, and that's how it is joined. So if you do a join like that, then what you see is, okay, this group is account, these 2 people are in the marketing group, this group is HR, and then Gaida is the supervisor for both of them, Stu and Mary, both are in the marketing team. So this is a many-to-one join, and there are various joins which you can do. Why am I talking about all this? Because these steps you normally do before applying any algorithms, and we will also be doing these steps on Microsoft Azure. Okay, So let's understand this file first, because on Azure it might not be very clear because there are other things. It will be clear for sure, but there will be other things to learn there apart from this basic functionality. So I'm giving a quick review of the file before I move to Azure. So data frame 5. Now you have a group, you have core skills. You can also merge these things based on group. So I define on is equal to group, which means based on the group I do this merger. So wherever is the group common, like the group here is accounting, so accounting's for Gary, and then core skill maths. So that means accounting requires a core skill of maths and spreadsheets. Marketing requires a core skill of writing and communication, and HR requires a core skill of spreadsheets and organization behavior. Okay. So these things are there, left on, right on, different types of joins. All these functionalities are there in pandas, and you can do a left on join, a right on name. So different criteria you can specify for joining various things. And let me see what else is there. Arithmetic joins you can do. Okay, you can join on a particular group, left, right, one sec. Okay, you can also concatenate various numpy arrays. So x is one array, y is another array, and z is another third array, and you can just concatenate them into one array. So this becomes one complete array. I can also save it in something like u. So this becomes u. Okay, I can also do a two-dimensional array because I concatenated x and x, but I defined x is equal to 1, which means they should be added column wise, not row wise. Okay, so I can define the axis. So this is how 1 2 3 4 was added, 1 2 3 4, and then next column 1 2 3 4. So I'll have two columns here and two columns here. I have now four columns because axis is 1. If I define axis as 0, then I'll have 1 2 3 4, and below that 1 2 3 4. So, or if you want to see, you see. So let's say if I do not do this axis 1, by default axis is 0. So if I do this, control enter, by default this is the axis. I have 1 2 3 4 and again 1 2 3 4, right? So I'm adding one below the other. So this is x, one 2D matrix, and I'm adding another 2D matrix below it to form a two-dimensional this kind of matrix. Do you understand? And if I define the axis here, control Z, and let's say if I do a axis 0, it is the same thing because that's the default. So it is the same thing, nothing will change. But the moment I do a axis 1, things will change because now I am concatenating them column wise. Okay, can I do a axis 2? I cannot do it for this. This will throw an error because this is a two-dimensional matrix, so it has only two dimensions, 0 and 1. Two axes are present, or in pandas you also call them row and columns. But means you can also use axis 0 and axis 1, but you can also use axis equal to columns and axis equal to row if it's pandas. But the important thing is that there are two axes, they cannot be more than two axes. But if it's a three-dimensional array, then I can have more axes. All these things we'll be doing also on the Azure. Then the pandas functionality, I have two pandas series, we can add them, we can concatenate them this way. So I say on A I have AC and on B I have BC. So I can have two records A and B, and I have A, B and CD concatenated to data frames. I can also concatenate them like this. I can have re-indexing done here. So ignore index will do a re-indexing, and then I'll have 0 1 2 3 new index formed. So all these operations are very common when you are doing cleaning and manipulation of dataset, which we do before applying an algorithm. Okay, and which we will do on Azure right now. Let me just see if there is something you do not know. So do you all know what is append class? Do you know how do we append a data frame? So I have a df9 and I want to append it with another df9. So append means I want to add something. On this data frame, I'm adding the same data frame. So I had something like A, B, C, D, this one 0 and 1, and I added again A, B, C, D. So I can also use the append command, which will be added towards the end. Here I haven't defined anything, so appending is happening on axis 0 or the row axis. If I define axis equal to 1, it will happen in column axis. So append command can also be used. And exploratory data analysis, there is one data set. Now let me show this file to you. Okay, the file is stored in my local system. So let me just share, because this is the part where I will also be showing you how to do this step. This is very different on how we do it on Azure. So let's say, let me show you the folder. Okay, wait. Let me open a folder and show you where the files are. sec. Okay. So this is the file housing_dataset.csv. You see the file? If you look at this is how the file looks like. You see the file? This is how the file looks like, class. Right? We can also open it in Excel sheets, but this is how the file looks like, housing_dataset.csv file. Now, is this screen visible? Is my code visible, class?
Yes.
Okay. So housing_dataset.csv is kept in the data folder. If you look at it, this is my data folder. Inside this data folder, this file is kept, housing_dataset.csv. Okay. So I'm reading this file. Now this happens slightly differently on cloud. On cloud, when we'll be doing it, cloud does not have access to your local folder. So you need to upload the data. You need to understand where it is saved on the cloud. You have to copy certain lines which will tell you the relative path of the data on the cloud, and you have to provide that path. Okay, so there are few changes, and we do not reuse the read CSV command there. Okay, so that's one of the change which will happen on the cloud, and it's an important change, registering the data set and how to read it in your machine learning model. Okay, which I'll be talking about in detail. Okay, so normally you read the data set, you can see the head of the data. This is your local data. It is not like Iris, which is pre-stored. You read the data set, you see what all is there in the data, you do a shape, and you know there are 506 rows and 13 columns. You do a describe, so whatever attributes in this data are numeric, like the crim is numeric, Zn is numeric, index. If you look at the data set, let's say, where is the data set? This crim is a numeric attribute, Zn, indus, chas, nox, rm, all these are numeric attributes. In fact, everything is numeric here. So, but if there is a non-numeric attribute like name, and some names are there, some strings are there, so describe will ignore that column. But if there are numeric attributes, describe will take each of those columns. It tells me the count, how many rows, 506. It tells me the mean of for crim. It tells me the standard deviation. It tells me the minimum. Tells me also the maximum, and these three quartiles, the first quartile, the second quartile, which is also the median, and the third quartile. I hope everyone understands these things, quartiles, 25, 50, 75%. Is the correct, class? Class, do all of you understand these standard deviations, mean, 25%, 50%, 75%?
Yes.
Yes.
Yes, sir.
So this is a quick command in pandas, describe, which helps me understand the numeric attributes and their distribution, how the data set is there for the numeric attributes. Quick command. Okay. But okay, so all these things I can look at individual things also, that for this data frame, for the age, what was the median? I'll get the same value, 77.5, but I can also look it from here. If I want to see age and median would be the 55%. So this is 77.5 is the value we are getting. Okay. So that's one thing. Then some more analysis, group by age versus MEDV, which is again attribute. MEDV, let me check. Okay, so this attribute, so age versus this, and then I want to find the mean. So for each MEDV, what is the mean age? Okay, so for 2.9, 26.6, 24.1, for each of the group, what is the mean age? So in each of the subgroup of MEDV, what is the age? Sometimes of this kind of analysis, or you can do the other way also. Let's say, what is the mean MEDV, which is the value for, let's say, age group between 25 to 30. So you can do it other way also, if you just put this later and that later, that first. Okay, so here we are doing in terms of age, what is the mean for MEDV, which is one of the columns. Okay. So you can do all this analysis, and age 50, you can use lambda functions here. So apply, what I'm doing is, this is a filter operation. Those who understand lambda function, they understand this is a filter operation. I'm saying is that for the age, apply this operation wherever it is true. The operation is x greater than 50, which means if the age is greater than 50, if a value in the age column is greater than 50, filter those records for me and save it in another data frame called age underscore 50. That's all it is doing. If you look at this, and if you look at this df, sorry, df, any questions, Clark? Anyone, any question? This, oh, I haven't run this dfd. Okay, so it is telling me what it does return is it returns true if this condition is satisfied. So for the 0 index it was true, true, true. For the third index it was not true, it was false. So there this person did not satisfy the criteria age greater than 50. Wherever it is false, it is different. If it is true, it is different. I can also do a sum on top of that. I can do a lot of things, but I can apply this. So now based on this application, if I say if this is satisfied, then do this. So if the age is greater than 50, I can put a filter operation. I can do various operations on top of this lambda function. But that's what it does. So I can apply these functions also on individual columns of pandas. I can do value counts. So all I'm looking at is, okay, how many age 50 data frame, how many were true and how many were false. So I see in the records of, let's say 350 and close to 150, somewhere around 500 people, I see approximately 360 people have age greater than 50 and approximately 150 people have age less than 50, less than equal to 50. Okay, so I can do these kind of things, these kind of computations. I look value counts for both of them for this data frame, and let me check if there is. Okay, I can draw these plots. This is also important. So, and the good part of working on local is if I draw a plot, I can use %matplotlib inline so that I can see the plot in Jupyter Notebook. So we would want to check whether we can do this in Azure also or not, or is it different on Azure. So I can use this matplotlib, and also I can do an inline there using the % symbol. I can do it inline so that I can see it in the Jupyter Notebook. So we will understand the changes what you will see. So at the moment what we are doing is we want to do bar plots for the column name CHAS, which has two values 0 and 1. So 0, this is the bar plot, and for 1 this is the bar plot. Okay, so we do a bar plot for these things, but we'll see can we do it comfortably in Azure. If not, then what are the things which will change. Okay, we are doing a correlation. Method is equal to Pearson is our default method. This argument is not required, so it's a default, but if you have to change, we can change. So I'm drawing a correlation matrix. So each attribute's correlation to itself will always be 1. So I'll see that in the principal diagonal I will have all ones, right? I'll only have ones, but for each of the attribute I can see the numbers. What is the correlation? I can do also a correlation plot, which comes very good in times. It is colored along with these numbers. Okay, there are various things which we do and which we usually do in data science, and we will see. So this like a correlation plot. So if I'm using a Seaborn, this plot is slightly more intuitive. Also I can put numbers here on each of the labels, so I know that okay, all these dark ones close to black or dark hue colors, they have high correlations, and these are low correlations. Okay, so and then histograms can be made. So I can use my matplotlib, I can use Seaborn. All these I've been using on my local. Now anything else? Joint plots. So two plots, MEDV versus RM. How is the distribution? How is the scatter plot? So in a very intuitive sense, these plots will help me analyze it. Okay, with increase in RM, there is a somewhat increase in MEDV. So this, if I draw try to fit a line in between, this will have some positive slope. And this positive slope means while I'm increasing it a little, MEDV increases a lot. So with a little increase in RM, the value of RM column, there is a huge increase in the value of MEDV column. So the slope could be something like tan 60 is the slope. Okay, but that's like a visual appeal. I need to verify. If I need to know the actual number, I can check MEDV versus RM. If I want to check the actual number, I can see here. We had the correlation plot. So if you look at MEDV versus RM, RM is here, and MEDV. So this is the MEDV, and where is my RM? This is my RM. Okay. So it comes to be 0.6953. If you look, right? So I know that is 70% correlated, and this 70% correlation is also expressed in this scatter plot. this seems that okay, with every increase in this, there is 0.7% increase in MEDV value. You get that? Approximately said 60, but 1060, it could be 1070, but there is some correlation. 0.7 is a correlation. 0.7 times correlated with this factor. So these visual plots help us realize that. Okay, there are other plots which we can make, which are common in Seaborn, and I can make all those plots on local. I'll have to see. In fact, I know that we'll be able to make all these plots on the Microsoft Azure too. All these, each one of them. Okay, but now that we understand that this is what we do usually in doing basic cleaning and analysis, I'll talk about how do we do it on Azure. Okay, so let's start the first steps. First thing is you pick an account. So if you go to Azure, if you want to go to Azure, what you do is you go to a new site and you do a portal.azure.com. That's the first step. Do you all see my screen, class?
Yes.
Yes.
Okay, so that's which one do you all already have a Azure account or not? Do you all have a Azure account, class? Class, does anyone of you has a Azure account, or do you guys don't have an account? Because if you have an account, I do not need to do these steps. I can straight away talk about how to do things on Azure. Okay, do you all have a Microsoft account?
No.
No?
No.
Okay, that's fine.
No, I don't have.
Oh, you don't have, that's okay. So it's important for using Microsoft Azure, it is important that you have a Microsoft account. So go ahead and make a Hotmail account or some account. I already have an account and I have services, but I'm showing you with a new account so that you will go through the same steps. If I do with my account, I'll not go through the same steps. You understand? So I want to show you what will you go through, which steps will you go through before you reach there. Okay. The important thing is,
Avinash, I have a question.
Yes.
Sorry to interrupt. So,
Yeah,
like in Azure Databricks also, like we can do Azure machine learning. So I had read somewhere like Azure Databricks, like we can handle huge amount of data, but when the data size is less, like we need to go for Azure ML, Azure ML Studio, and also we can integrate Azure ML Studio in the Azure Databricks. That is what somewhat I had read it. So what's your say on that? Like when about the data size?
I'll tell you what is the difference and how things are different. Okay, so let's understand when you talk about Databricks, which produced Spark and all. This Databricks works on distributed data sets. So we are talking about big data loads which cannot be stored on a single machine. Okay, so right now when you do machine learning on Azure, it's like putting your data on the cloud, but the assumption is all your data can be put on one hard disk or on one machine. Okay, so you will see on this account that I take a compute from Azure. So that means I tell them that okay, I need 30 GB of hard disk space, I need 4 cores of processor cores, I need like 14 or 16 GB RAM, whatever I need. I take all those things in my compute. So that means my data which I have taken, let's say I have taken a hard disk of 30, so I cannot have more computations which need more hard disk than 30 GB. I cannot do a computation which requires more processors than what I have, and I cannot do a computation which requires more RAM than what I have. What is big data for me? Something which requires more than this. Let's say I have a data set of 1 TB, so I cannot work with 30 GB. What will I do? With Databricks, what they do is, Databricks are the ones who started this Spark and all. Okay, so what they do, they have this framework for distributed computing. Have you guys heard about Hadoop and Spark, these tools? Anyone else? Yes? From? Okay. So if you've heard about these tools, what they do is they provide you an API so that it looks to you as if you're working on one machine, but at the backend, the load is distributed on various machines. Okay. Databricks provides one such services on the cloud. So that means if you have a bigger data load, you put it on Databricks, then Databricks, although it did not tells you that how many different machines is the load put on, but your load might be distributed on 100 different machines. And it's not just that load being distributed on 100 different machines. The load in big data environment is also copied at times. Three is the usual default copy size. So I have a data load which is put on 100 machines and then also copied on 200 more machines. Okay, and why is that? So that if one machine goes down, the entire system is not disrupted. If one machine is not working, I still can access my data. I can also increase the number of copies and I can also decrease it, but by default it is 3. So now if the data load is distributed, the regular machine learning algorithms do not work on it. In that scenario, you need distributed computing algorithms which look like these ones, which look like your regular linear regression and logistic regression, but those regression algorithms are not the algorithm inside the library has the same name, but within the library the specification of the code is not the same. So those distributed algorithms are available on Spark. The like Spark ML has those algorithms, which is distributed computing. They are also available on Mahout. They are available on Flink. There are various tools on which these machine learning algorithms are available. Those algorithms have been written to deal with distributed loads, because when I have data set distributed, usually a machine learning algorithm needs all the data, and then in the first iteration it will see the result, then try to improve it in the next iteration. If you understand the algorithms mathematics, you will understand that it needs all the data. But assuming that I do not have all the data in one machine, so I get part of the data, I do part of the work, I wait for the other part of the work, so the algorithm needs to be modified accordingly, so that also it is optimized, but it does nearly the same job which a normal algorithm would have done on a standalone machine. So for these needs, when we have bigger data sets, we definitely would prefer Azure with Databricks. That is the that would be the default case, because that will be a lot faster. And it is not only bigger data loads. At times it is like you have to make quick decisions. Let's say I want to do fraud analytics, and I know that if someone is swiping a credit card on a merchant shop, they take 10 to 15 seconds to make that transaction, even less. Maybe at times it's like 3 to 5 seconds they have for the complete transaction, in which the transaction is either approved or disapproved. Within those seconds, there are like thousands or maybe 10,000s of transactions going on simultaneously for the same, let's say, type of card, like for Visa or MasterCard. Simultaneously, there could be more than 10,000 transactions happening at a particular instant. Then these transactions go to Visa, the card is approved, then it goes to your bank. Your bank looks at your credit limit and does the approval that whether you have enough money to spend or not. And then finally the transaction is approved or disapproved.
Hello?
So, yes. Hello.
Avinash?
Yes.
Hello?
Am I audible?
How secure the data will be? Like, for example, if we upload the data related to the financial transaction, so a lot of security is required, right? Like, how secure using Azure?
It depends. Then this security is something which, so there are a lot of banks who keep their data on Microsoft Azure, but none of the banks in India do so, because we have our laws which prohibit, RBI prohibits any bank to keep their data on the cloud. Okay, so banks usually have on-premise, but then there are various retail joints like Amazon's and various banks in US and Europe who keep their data on the cloud. So when it comes to security, you need to, let's say, you need to ensure that what kind of security you're looking for, and with if you are happy with the provider and their security or over their cloud services, you can go for it. So the intent of this session is to help you understand how to work on the client if the client already has the data on cloud. Okay, it is not to make the client put their data on the cloud. So we just want to be comfortable. If the client says that their data is on the cloud, we should be comfortable working on the cloud. That's the intent of this session. But yes, there are various laws. So in India, they do not allow banks to keep the data on the cloud, whereas all Europe banks, and there are many banks whose data has been completely on the cloud right from the beginning. Okay, so definitely the security is a concern, but security has been a concern even if you have the data on premise. So there could be security flaws and people can get in, and you have to ensure that the security is consistently monitored and updated. And Microsoft and Google and, let's say, Amazon, they have been providing these cloud services, and their security is by far the best in the world. Their cloud security. Okay, but yes, things could happen, data leakage could happen, and no one can guarantee it even on premise. Have I answered your question? Am I audible?
Yes, yes.
Yes. Okay. So security is something which let's say if someone wants their data to be on cloud, and they will talk to the cloud guys and they will ask them various questions, and maybe they could ask for additional security for additional price. Various things could happen. Okay. They could ask them to set up things on premise, although maintain them themselves. So there could be various aspects to it at the time when someone is cutting a deal. Also, comparatively, so there are a lot of things, but let's not get there because that's not the focus of this session. Second, so what I was telling was, apart from the abundance of data, another reason for moving to cloud is if I want to make quick decisions, decisions like I was talking about making a transaction, and you have to do a fraud analysis. You have to identify a fraudulent transaction before the transaction goes through, and maybe the time for identifying whether the transaction is fraudulent or not is in milliseconds. So you have like 10-15 milliseconds to make that decision, and you have like several transactions, more than lakh transaction going at the same instant. And within these 10-15 milliseconds for 1 lakh transactions, I have to tell whether they are fraudulent or not. So if I have a very capable data science model, that model which is built in batch, and it is very good at identifying whether a fraud is happening or not, that model's decision should come in milliseconds for, let's say, 10 to 15,000 or at times even 1 lakh records, depending on the kind of bank and the kind of transaction happening. So there should be a tool which supports it, and it cannot be supported by one machine. So again, we need big data, we need such servers which can support multiple machines, giving their compute to a single job, solely to like multiple threads working towards just looking at whether a transaction is fraud or not. So the application is less, data is also not more, but the decision time has to be very, very quick. So I need multiple machines to work on it. Sometimes the data is more, therefore I want multiple machines to work on it. So there could be various reasons. Sometimes the velocity of data, the data is coming very quickly. Let's say Facebook page is updating very soon for several customers. So the data itself is not more, but the data is updating very quickly. So I need multiple machines. So there are requirements where big data is the only option, and then I go to Azure with I want cloud services, but I want it along with big data. Okay, so that's the answer for that part. Now let's look at this. If I have to do a regular ML, although we can also do on big data, the process is nearly the same. It's just that do we have the service or not. So let's say this is my new account. I simply added my ID and password. What I'll do is Azure service, I do a create. So I want to create a service. Here I can do something like AI plus machine learning. AI plus machine learning, and I can pick machine learning. I can pick many other things, computer vision, web app bots, many other things, text analytics. But let's say I'll pick machine learning. I pick machine learning, and then it gives me an option for creating an account. And the steps are, you start for free, you'll have to create an account, and let's say you select start free, you have to create an account, and then I hope you saw these steps. You create a service, you choose what you want to do, you create an account, and your new account will be created free for 12 months. Okay, so this will be free for 12 months, and after 12 months of free products, you'll have 13,300 credits on the account. You have 25 plus free products. There are no automated charges. So once you have the account, if you want after a year you want to have their account, you'll have to pay for them. Otherwise they'll ask you, but they will not automatically charge your card. But this is important because you have to provide your card to start the account. Okay, so this is how a new account works. And here this is where identify verification of card, when they detect 1 rupee from your card and they return it within 48 hours, just to verify that the card is authentic or not, and the user is not an authentic user. Okay, so this is how you can start for services. But I already have an account where I have my card and other things, so I'll go to that account. Just to understand once again, how do you do that? You go here, you go to the home, you do a Azure service, create a resource. You can choose AI plus machine learning. You can choose any of these, whether computer vision or WhatsApp bot or text analytics, web bot or machine learning. So let's do machine learning, and then you do a start free, and you do a start free, you click again here and you fill in all these details, you provide your card, and then you get up a free account with 13,300 credits, and I'll explain what are these credits, but you start a free account here, and then you can verify your phone, your card, and all this. Okay, and you can read these rules and regulations. Okay, that's for learning purpose. That has to be an account for learning, and I have a Hotmail account and I'm using it for Azure, so I'll take you to that account now. So once you do these steps, check this account. So this is my account, this one. This, if you look at the account details, this is my account. Okay, so in this account, what you can see is that I created a resource, and I have this resource training. Okay, so we'll go to this training resource, and right now it is created, so I get this option, Azure Machine Learning Studio. Well, I'll also walk you through how this entire thing is set up. I'll show you things. Okay, so at the moment, let me launch now. So I'm launching the Machine Learning Studio. If you have a Databricks tie-up, the entire step is very seamless. It will work in the same fashion. Welcome to the studio, and let's say I go to the default directory, subscription, free trial. Give me a sec while this is loading up. Okay, so let this load up, and meanwhile, okay, start it. I don't think I need this. Wait. So I have this. I do not need it. Oh, I was doing a new compute. That was not required. Training, activity log, compute. So if I need additional compute, then you saw we had this 30,300 credits. So I have just taken the free credit one, and this is my compute. So let's go here. That's my compute. And how do you set it up? How do you switch engines? I mean, so you have to provide these names, like my compute one is the name I said, computer instance, there's a subscription ID, there were some details. These are the machine details. The first time I need to set up these details. So there was one option, 4 cores, 14 GB RAM, and 28 GB disk. That's the option. The standard DS3 V2. So that's a standard DS3 cloud machine with 28 GB disk, 14 GB RAM, and 4 cores. That's what I've taken. This is a CPU. You also have an option of GPU here, where you can take GPU for purpose, the way it is on Collab. Okay. And application URI, so I have taken RStudio, I have taken Jupyter Notebook, and Jupyter Lab. These are the 3 things. And this is what it was created. Okay, so it was created on July 20th. Yesterday I created this. So this was the first subscription I took, which is all free of cost. And now let me take you to other fields which I have here. So
what's the difference between Jupyter and Jupyter Lab?
Jupyter and Jupyter Lab. So let me just check. Within notebooks or scripts, give me a sec. So Jupyter Notebook is the regular notebook which I maintain on local. Okay. Jupyter Lab is a notebook which I create on Microsoft Azure. But on Microsoft Azure, you start with the Jupyter Lab notebooks, but if you want your regular notebooks to be uploaded directly, so I have that option. So I also take Jupyter, and then my regular notebooks is uploaded directly. From the local, I upload the notebook. From the local, I upload the data, or I can do a web link and upload it to Drive or somewhere else. Once it is uploaded, once I have uploaded these things, then that can be internally converted to a Jupyter notebook and be converted to a Jupyter Lab subscription. Okay, so there is not much detail. There are few changes. A usual Jupyter notebook will not work. There are a few changes here and there. That is, how are you reading the file? How are you doing various things? These changes are there, which we need. Let's go through an example, then we'll understand. Okay, let's take an example and we'll understand that. Is it okay?
Can we
Yes.
use Anaconda in place of Jupyter or Jupyter Lab?
Yes, so at times I'll have to install things. I have to do a conda install. I have to I go into the command prompt mode. I'll show you all those things. So whatever I do in local, I can do all that on Azure.
Okay.
Do you understand that part? Right? So sometimes you have to do, let's say in my file, so there is another file. Let me just show you on the local. So there is this another file, machine learning models, which I'll be showing you today on Azure. So on these machine learning models, I have this. How many of you have run decision tree in the past? Has anyone run? Class, have you run decision tree in the past? No? Okay,
No.
so decision tree are one of the type of algorithms. Now these tree needs some package called GraphViz is the package. Now this package cannot be installed on Jupyter Notebook. It needs a conda install. Okay, so you need to get into command prompt and you can plot the tree. So this is not doing anything for machine learning, but it is creating a plot for me. Let's say this is not visible because I have done depth 5. Let's see your depth 2 and you can understand how this looks like. So let me just run it all. Restart and run all. So I'll show you how it looks like. But so intent is there are few things in which I need to go and install in the I'll have to forge it in the Conda. So those things are available even on the cloud. So I did it on the cloud and therefore I'm able to do it here. Otherwise I cannot do it, right? So those options are available even here too. If you get my point. So I'll show you one example. I'll show just for these trees and all. What happened? Did I not import? Anyways, leave it. I have it on the other machine and I've done it on the cloud. One sec. Okay, so Azure ML workshop resource training why am I required to do this? Notebooks. And cleaning and do you remember this file, cleaning and manipulating files, which I just did for all of you? Yes, I just did this file, cleaning and manipulating data, right? This is what I'm trying to do on Azure. Okay, so let me just load the file. This is the cleaning and manipulating data. How I did was, this is the option. Okay, let me just lessen it. Let me first show you the option how to upload this file. So what I did was, this is the option for upload. If you look at this is upload files, right? So I can go here in the notebooks. I can upload my notebook. So I go to the upload file and I can upload from the local. So now you can understand, I can go anywhere into some folder and let's say I go there and I go here and this is my cleaning and manipulating data, right? And this is how I uploaded it. I'm not uploading it again, but you understand that, right? So you can directly upload these files here. Again, the machine learning models file, all the files you can upload it one by one. You can just do a left click so that you have a bigger screen here. Okay, so this is the same file and we can run it. Let me just remove everything here. So I have the option of, let me just do a restart and run all cells. So I'm running all the cells again after restarting the server, and this is iris.info. So you see the info has come. Slowly you'll see that all these things will come, whatever we did on the local. Tail, head, all these commands, example 3, it's the same file. Although we'll have to live with the view. So if I try to make it very big, there are things which would, other things which I'll not be able to explain. But if you see that file till this command, there's all these plots, right? If you compare it with my local file, this is my local file. This is the local file and these are all the plots, right? So if you look at this, you can have everything on Azure too. Class, do you see that?
Yes.
Yes. So you can run everything. Now the important things which you need to know. So this is where I took the compute. So this is the plus button. So you see this plus tab, you do a plus tab, and what all can you do? You say a compute name. So I said my compute one, right? This is where I choose CPU or GPU. Okay. Class, do you see that? This is where I choose CPU, GPU. There, this is where I can choose this virtual machine size, the cores and other things. Okay, so I'll just cancel it. I don't need more. But if you understand, this is where I add a compute. Once a compute is added, you have these things. So you get this Python 3 R and Python 3.6 with
What
Azure.
is SSH type?
I'm sorry?
What is SSH type? SSH type.
Secured service layer. So this is more to do with networking. So I'll talk about it once we are going to understand how data set has come and how are we relating with it. I said that there is one difference in this file, and the difference will come. So if you look at my local file, I'll just explain you where the difference will come. So where I'm reading this data, I did mention that you would not be able to do so on Azure because Azure does not know the path to my local system. So let me see. Where this read CSV, control F, read. So you're doing this pd.read CSV, right? And which is on my local file system, right? The entire this block is changed in that file, and I'll show you how that is working. Now if you go to this file, manipulating data, everything is fine. Iris data, I'm loading the import, that has come, info has come. I can read the iris data, everything is okay, but these are the simple example 1, example 2 examples, null values. It's exactly the same file. Let me see where we are reading the file, pd.read CSV.
So what's the difference where you see the option for Python 2.6 Azure ML and Python 3? So what's the difference?
By default, it is Python 3.6 Azure ML. So that means the Python version which is in sync with the Azure's machine learning library version. Okay. By default, it is that. If I want to update it, let's say I use my own Python version. In that case, I can do and install it in Conda, and I'll show you how to do it in command prompt. And then I can also update the other updated libraries in Conda. Let's say scikit-learn. Let's say other libraries. I want to update a package there, so I can do that. Okay. So these are the things for which Azure has provided all the libraries, so I do not have to do anything if I use 3.6 Azure ML. But let's say I'm using 3.8 and some libraries are not in sync with 3.8. Then I have to separately upload it on the command prompt. I'll have to install it on my machine. That is my compute machine, this 28 GB SSL disk. Concat, append, okay, this is the place, exploratory statistics and visualization. Now in this place, if you see, I have commented these lines. So if you look at my local file, this was the place, exploratory statistics and visualization, and these were the lines for the local file, right? You see the screen, class, right? Now when I uploaded this file, I ran this command. I know this is the place where the error will come. How do we go about it? So you need this paragraph of code. You need this. What you're saying is from Azure ML.core, because you're not using actual packages, you're using the Azure ML based package. From Azure ML.core, you need to import Workspace, data store, and dataset. These are three things which you need to import. So you will just copy paste everything what is written here like this as it is. What you will change is you will change this block this data store name, and you will change data store relative path, and I'll tell you how will you change it. So you will copy paste this entire code every time you are doing a machine learning algorithm and you are reading a file. For instead of writing this command pd.read csv, you will just first copy paste this entire code, and in this code you will edit these two lines. I have put them differently, a data store name and data store relative path. I've kept them here. I'm using this data store paths here, and I'm using the data store name here. If you can see this is this data store name and this data store relative path, but instead of keeping it here, I'm just making them the first line. Okay, and I'll tell you, you just configure it, replace it every time, and just use this method as it is. Okay, so what is this data store name? So first understand that this file is using the housing dataset.csv, right? Now this data was there on my local machine. I need to upload the data, so I'll go to the data section. I'll go here, this is datasets. I'll go to this section in data, or let me just go remain on the notebooks. Let me just be on the notebooks. Okay, so this is where I'll do it on a new tab. So let me just do the data sets on the new tab. Okay, so that you keep looking here and there both at the same time. Okay, so this is my data sets. I did this, I did open in new tab. That's it, all I did. Okay, so this is the data set section. You see I've uploaded a data file, housing data sample. Okay, simple way. You can just, if you want to upload any file, all you have to do is you do a create dataset from local files, and then you give a dataset name, any name you can give, XYZ. You check the dataset type. If it is image file, is it tabular data like rows and column structure? So ours is a tabular data. You can skip this option, and you take the default store is Workspace blob store. That's Azure blob storage. Okay, but you can pick other storages also if you have bought them. On the free account, the default storage comes. Then you can browse, and this browse will take you to any file on your system. Let's say I want to upload some other file. Let's say I'm here and I want to upload, let me check this, and let's say I want to upload some file like this. Let's say empty.txt or train data Titanic. So I can upload this file. Okay, so now this file will be uploaded. If I do a next, it will be uploaded. If I do a next, this file will be uploaded. I can give a sensible name also. I've just given XYZ, but that's not a very sensible name. Give a name which makes sense. Like for in these cases, I gave a name housing data sample, Titanic data, regular housing data. This was just for talking to you guys. So I've given a name. Then comes this screen where I select what kind of the file was tabular. So is it a delimited file? Is it a CSV, TSV, comma separated, colon separated, tab separated? What kind of file is it? So I've mentioned it is delimited. It's not text, it's not Parquet, it's not JSON, it's delimited file. And then delimiter, which delimiter am I using? So am I using comma in this file? I know that. I can open the file and check, and I know it is comma. But if we are not using comma, so by default it is taking comma, you can just change it to semicolon or colon or equals or custom delimiter, you can put it here. Okay, so you make this change. After that, encoding by default UTF-8. If you want to change anything, that's it. Here, if you see the data set, you see there is a passenger ID, survived, P class, is Titanic data, right? You see these details are there, but these details are coming at row 1. Why? Because there is no header. I can select, okay, no header. I can just select use headers from the first file. What will happen is this will start appearing as headers: ID, passenger ID, survived, P class. Now this becomes header, and this is my actual data. Class, do you understand that? Right? And next, so this is the attribute which it has detected, path. And if you look at the attribute type, path is a string. This is a passenger ID is an integer, is survived is an integer. This is again a string. So it detects some, and if you want to modify it, let's say this is detected as C85 null as a string, you want to modify it, you can modify it to some other attribute type also. Okay, so you have an option. It's simpler than Python. So you can modify the data type right here. Okay, next you do, and now finally your data set, this is what I named DDDGGG, okay, which is nothing but the same data as Titanic data. Okay, so data file is created, is registered. I want to remove it. I just click on this and I want to unregister. That means it will forget the file. Okay, and now I go to data sets again, and it has just the 3 files which we started with. So first thing, how to upload the file. I hope everyone understood. The step starts at create data set from local or from web or from data store or from open data sets, wherever you want to go. Easiest thing, from local, you write a name, select the type, you go next, 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 third, select the options, look at the various delimiters, look at if the data type has been correctly detected or not, or you want to modify it. Do all that. The data set is easily uploaded. Once it is uploaded, now what is the next thing? Next thing is, I am looking at housing dataset.csv. I know it is uploaded. I go to housing dataset.csv, and this is my housing data. Is it sample or regular? It's a regular data. Okay, so this is my housing data. This is my CSV file, and now data store, because I have kept the default store, it is Workspace blob store. You remember I talked about it there. There I could have modified it also, but I know that it is Workspace blob store. So I know the data store name, and the data store name, if I'm keeping the default, will always be there. This is where I put data store name Workspace blob store. Is that clear, class? Next thing is data store relative path. So if I need the relative path, I need to know the relative path for this account. So I go to data stores, training, no, cancel. I go to data store, Workspace blob store, refresh, data sets, housing data. Okay, this is the relative path. So the data store name is Workspace blob store. I do not need, I can also go into inside the data store and check what other is there, what other things are there. For other projects there might be other things, but I just have one project, so there is nothing else. But this is my relative path. The relative path is UI/07/2020, which means the relative path starts with, it has the file name from where I uploaded, and the file name was housingdata.csv. That name is there in the end, but user UI is user interface slash, and then it is given the date. So yesterday I uploaded the file at July 2020 at 11/11/14:50, whatever was the time as per UTC. So that UTC time slash my file name. Okay, so that's my relative path in the system. If I give this path, then the cloud will identify that, okay, where the file is. That's how the file is saved with this name. Is that understood, class? So I'd go ahead and I put this here. Okay, so these are the two things I change: Workspace blob store and the relative path. And also what I do is, towards the end, I know I call it housing DS. This could be any variable, but I can just keep it DS or some data set, but I call it housing data set. Now understand that data set is a variable of, is a object of data set, is a particular class of Microsoft Azure. Okay, so data store, data set, workspace, these are all for Microsoft Azure. And I'm using it one by one here. I'm getting workspace, data store name, various things I'm getting. But what I create, this thing, housing data set, is actually a data set. So Python's Jupyter notebook does not understand it. So once it is done, once it is read as a data set, once I have a file as a data set, because I have provided the relative path and I provided the data store name, the file in Azure is read as a data set. Once it is read as data set, the next thing I do is I convert it to a data frame. So a regular Python data frame is whatever data set I have made. I have named it housing data set, the housing underscore DS. I do a dot to pandas data frame. So that data set is converted to pandas data frame. Once this is done, this is step df is equal to housing ds to pandas data frame. This is equivalent to this state. This is equivalent to pd.read csv. So right now when I do a pd.read csv and store it in a df, that means a data frame is stored from a csv file. If in Microsoft Azure I want to create a data frame from CSV file, my steps are, I first take a CSV file, I upload the file, I understand the data store name, I understand the relative path, I store it in a data set, and I convert a data set to the pandas data frame. Okay, these steps are equal to writing p.read CSV in your local file. Is that clear to everyone? Class?
Yes. Yes.
Okay, nothing else changes, and you can see that I'm running the entire file exactly same. This is where I've changed, so therefore I just commented it because I uploaded the same file, so I just changed these lines. I also have to go and see and work on it to understand what changes it is taking. Okay, So these are the changes, and the entire file runs exactly the same. The entire page will be shared with you, the video will be there, and if you follow the entire steps, you'll be able to replicate the entire file exactly the way I'm doing. Okay, so this was an easy file, this is just a cleaning file, but we haven't run any data science models till now. So I'll just show you one more file where data science models are running. Okay, so I go to another notebook, and this notebook is machine learning models. Okay, if I show it to you on local while it is loading here, this is the notebook machine learning models, and this notebook is all about creating a linear regression model, a logistic regression classification model, and a decision tree models. Three models are there. Regression is there. uh, so housing data set sample CS3, and then you are regressing and finding some values. You do a model dot fit. Let me just show you. So visualization is there. You divide the data into train test, you keep the x separately, y separately. Do you know these steps, class? Have you done this in the past or not?
Avinash, I have a question here.
Yes, please.
See, you have right now uploaded that CSV file, and then simply you have accessed that from here. But let's say in the organization, multiple people want to work on the same data set. So I would like to put it on the Azure's storage account, right? So can I
Yes.
access that directly here?
Oh, yes. So what do you say is, so if you have a commercial account, it's not a free account, then you do not put it on data store blob storage. So that's a very good question. That is the question which is related to the Azure training. Okay. So when I go to my data sets, let's say I go to my data sets, here I put it on Workspace blob store. So this is the default data store for me for this account, right? But if I have a commercial account for my organization, there is a data store for that. This is free, and this is for me, where by default I'm just putting any data I'm putting, it's come here. But if I want to create a location which is accessible by multiple programs or multiple users simultaneously, I can do that. So at that location, one repository of data is there, and whoever wants to access that data, they import it from that location. So you go, you see where the data is, in which data store. Like we went into data stores. So if you can go into data stores, you can change data stores, you can copy it to other places. Within data stores, this data store was created when I created this account. Okay, this is just the training data store, which is created along with the account and some authentication with my card and all that. I'm an authentic user. But you have commercial accounts where multiple users would want to work on the same data store, and they can also have admin rights, so that within the data store some of the users may have accessibility, but others may not know the path but may not be able to access the data. So I can exercise those rights also. So
So do
those
you mean
were
to say that
read
instead of this,
rights and write rights. Yes, please.
so instead of this relative path, I can give that endpoint URL of the storage account? Will that work?
Yes. So
Okay.
that endpoint URL will work. So at the end of the day, you need a path, right? So any path, you would not know the endpoint path. That path which you think is the endpoint path is also a relative path on the cloud. Okay, because we do not know actually how Microsoft is storing it, right? Whatever path Microsoft displays. So I can define the data store. I can define a shared data store where certain people have access. I can select the data store, and once I've selected it, on that data store, based on my admin privileges on or my privileges on my ID, some of us can access data. Some of that can simply read the data. Some of also us can also edit the data and save new data records. So multiple things could be done based on the access rights. Uh, I believe that is how organizations work. But for training, you understand that in this code, when I'm trying to read the data in place of relative path, I'll place that path wherever the file is. Okay, it's the same thing. It's asking me where the file is, and I can also change these names. These were default names, but let's say I want to keep a different name, I can do that. Is that clear?
Yes, yes. Thanks.
Makes sense. Okay, so apart from that, I can also increase or decrease the compute power depending on my requirement, and various other things I can do. Let's say introduction to machine learning models, and again, let me just run all. We have less time, but the in so I am assuming that okay, this will take some time to run because this is doing machine learning. But meanwhile, I'll explain on the local file. Okay, So I am again assuming that you all know how to build a machine learning model on scikit-learn. Those who do not know, let's understand what we do in data science. Let's say in this case, what are we doing? We are using pandas, numpy, all these packages are used. After that, what are we doing? We are reading the CSV file. This step will be different. If you want to see for this step, reading the file, what am I doing? Here for reading this file, importing is same. I'm importing all the libraries, and for reading the file I'm again doing from Azure ML.core. Let me just make it big and let me just improve the font. You see it? So this is fine, data exploration is fine, reading all the files is fine, but when it comes to records, I am using the same lines from Azure ML.core import, and I am providing the works data store name. I'm providing the relative path. This is for housing data set sample CSV. This is the part. So if you look at here, this is not for housing data, but another data set, which is housing data sample. You see the data store is workspace, blob store is relative path is this. So I've just copied and kept it here. Okay. So the rest it will read. I'm changing it to pandas data frame and then doing it df.head. Let me just explain the rest of the code because I'm reading two more files here. Let me quickly explain this code. So I've read the file. I see there are 5,000 rows and 6 columns. I see all the column names. I see the head and tail. I see these are the column names. What I'm trying to do, I'm trying to predict the price in terms of the rest of the data set. So in terms of area, age of the house, number of rooms, number of bedrooms, and the population, in terms of all these things, I'm trying to predict the price of the property. Okay, so I'm using a regression type of model for numeric attributes. I've done df.describe.transpose, looked at all these values. This is a usual way of doing basic exploratory analysis of data science before you get into model building. So I did some analysis. I separated the x's from the y. By x's I mean that all these attributes, these are my x's, the independent variables, which are these: area, house age, so these things, everything except the price. Price is separate. First column, second column, third column, fourth column, and fifth column. These 5 columns are separate. Sixth column is the price, which is separate. So what I'm doing is I'm segregating it. That's the usual way. I'm saying that okay, take everything till before the fifth column, and here just the fifth column, the price column. So I have a x, I have a y. I'm also distributing the data into train and test. I'm splitting the data, saying okay, keep 30% for testing, rest 70% for training, and after that I'm importing the linear regression model, which is from scikit-learn linear models. I'm importing the regression model, and once the model is prepared, I'm calling the fit method, which is the scikit-learn's way of training the model. So I called reg.fit. Reg has linear regression model, and I'm fitting it by passing it training x and training y, which means I have passed the data set all these attributes. I pass the data set these values. Let's say this average area, income, this attribute, this attribute, this attribute. So all these 5 values I passed, and I'm trying to predict the 6th value. Because it is a regression model, how does regression model do that? Regression model will say that let's say this is my x1, x2, x3, x4, and x5. So regression model will try to find the appropriate weights for each axis. So it is saying that okay, price can be represented in terms of area of the house, age of the house, number of rooms, number of bedrooms, and the population. Price can be found in terms of these independent attributes, and these attributes may be linearly related. So that means I can say that let's say the weights are W1 to W5. So I can say W1 times the first attribute x1 plus W2 times the second attribute x2 plus W3 times the third attribute x3 plus W4 times the fourth attribute x4 plus W5 times the fifth attribute x5 plus some constant k is uh, is helping me find the price. Okay, so I try to find the price in, so I want to find the values of W1 to W5, these 5 constants and one constant k. and then I predict a value of price which my model is doing, and whatever my prediction is, I compare it with the actual y value. So I have an actual value, and actual value minus my prediction is the error which I get. Okay, and then iteratively I'm trying to modify the weights w1 to w5 and the constant such that my error is minimized. Okay, and that at the core this is the linear regression algorithm. This is what it does. Is that point clear, class? Class, does it make sense? Do we all agree that this is what linear regression does?
Yes.
Yes. So this is the core of linear regression. I'm just explaining it for those who do not know, and I'm not getting into how it does that, and I'm not getting into the maths because that's not the focus of the session. But yes, and then what we do is we distribute the data, and after distributing that data, we pass the data for training, which is the reg.fit. This method res.fit, I'm passing the training data. So it is looking at the x values, trying to come up with w1 to w5 plus the constant. Whatever value is predicted from the train, it is comparing with the y value of the training set and then finding the error. And then the gradient descent algorithm, which is underneath linear regression, is trying to minimize this error to find the optimal value for weights with the constant so that the y train minus x train is minimum. In fact, it is trying to minimize the mean squared error, not just the regular error. The squared error is they are trying to minimize for each and every row of the data. Okay, so that is how that is what reg.fit does. And once the model is created, the model can predict the value for the test data. So I call the predict function, and these are the predictions. So that means these are the values for the test data. For y values, I can also find I have the actual y values. So y values minus the predicted x test, I can just subtract and find the mean squared errors. Okay, and if you look at the model has this intercept, which means this is the constant, and these are the weights w1, w2, w3, w4, and w5. These are the weights for each of the 5 attributes. That's a linear regression model, which is like w1 x1 plus w2 x2 plus w3 x3, w4 x4 plus w5 x5 plus this intercept, and this is my equation. And this model has some error, and the error is we are trying to minimize. If you want to see how good it is, so we'll see that it is performing 92% better than just predicting the mean of y. So if we have been just predicting the mean of y, instead of that, if you're using these attributes to regress and predict the value, you are 92% better. So that means the model performance is, it's like you are able to predict the value of y up to 92%, 0.92. Okay, so which is the r squared, although we have to look at other things, adjusted r squared and many other things here, but the intent is, yeah, model without much work is also doing fairly well. And then you have these plots which you want to look at. After this, there is this logistic regression model, and the logistic regression model also, this is using on the Titanic data set. On the Titanic data set, if you see logistic regression model, or these attributes are there, then on these attributes, what you're doing is you are doing a classification of whether someone survived in the Titanic mishap or they drowned. And then there is a data for survived and drowned. And once you check all the data set and all the info, and you see a ratio of, let's say, is it the case that males survived more versus females, or a lot of things you look at in the exploratory analysis. But finally, you would, and you see all the correlations, finally you would want to come up with a model. So you do a train test split, and the scikit-learn's API, the good part is coming up with a machine learning model is very easy. So this time we want a logistic regression model, so we import it, we save it in a variable called lr, we do a lr.fit, and after doing a fit we can also predict. Okay, and the prediction would help us evaluate the model. Like the logistic regression model, which can be used for classification, which is just classifying survived passengers versus not survived with a linear plane. I can have a decision tree models which can also do the classification and do it very well. So after the logistic regression, I can also import. So this is the logistic regression model, and I can check the accuracy and all. And I see that, okay, it is 83% precise, 90% sensitive, and this is the F1 score. Do you all know what is a confusion matrix, class? Class, do you understand what is a confusion matrix?
No.
No.
No? Okay. It's a good thing to
Actually, I have a doubt actually. In the model, we specify the loss function, the optimizer, the learning rate, and all those things.
Yes. Mhm.
Those will be because we have not used here in these models, right? Um,
You can, so any model you want to do, let's say you want to, so you want to use logistic regression. We haven't specified anything. So these are
yes.
the default things which come. So C has a weight 1.0, class weight is none, dual is fault, fit intercept. So if you want to look at this, you go
Okay.
to sklearn logistic regression. In fact, any modeling, because you are new to data science, whenever you are doing it, so you understand what are the parameters which you can set. So we are taking just the default values, but these are the parameters. So if you go to this page, in this page you will see that okay, you can specify the penalty. It can be L1, L2. This is a regularization. So L1 type, if you know what is regularization, so we can have L1 type, which is the lasso, L2 type, which is the ridge, the elastic net, which is a combination of lasso and ridge, and none means I do not have any regularizer. By default it is always the lasso, that is least absolute square shrinkage, and it's lasso because that removes the variable. So by default scikit-learn prefers lasso, but you can always go ahead and change the regularizer. Okay, then
Okay.
you can specify dual, default is false. That means that which kind of solver are you trying to use. Okay, and there are a number of options which scikit-learn provides, and you can experiment with it. With learning of data science you will also learn more about it. Then you'll have this fit intercept. By default it is true, that means it will have an intercept value, but if you want the line to pass through the origin and no intercept, so you can do a false. Default is true. uh, there is another package where the default is false. There is a stats package where if you look at fit intercept, the default is false and you have to make it true. So you can always look at the default values from here. Intercept is scaling. Do you want this intercept to be scaled, the entire data to be scaled between 0 to 1? If you want scaling to be on or not. Do you want the class weights, if the per passenger survived were, let's say, 10% but not survived were 90%, then do you want a scaling? So there are various things, because with imbalanced class, different problems occur when you are doing a classification. Although it is not the case in this data set, so scaling was not required. But depending on your knowledge of data science, you can always set these parameters. Okay, all these parameters are available for every model, for linear regression, logistic regression, support vector machine, KNN. Every library, machine learning library, has a bunch of parameters, and based on your knowledge of the data set and the algorithm, you set these parameters. But for starters, if you do not know anything, if you just run with the default parameters, that's good enough to work with. And then you learn with, let's say you're working in a team under a data scientist, so he will explain you why I would. So let's say I see that the, let's say, fit intercept was true, that's fine. I do not think, let's say class weight is none. If I see the weights of people who survived versus not survived, if I look into value counts and I realize that people who survived were very less and mostly people did not survive, then I see there is a class imbalance. So I'll not do weights as none. In fact, there are two more options here, balanced and other options are there. So if you look at this, there's one option which we definitely set. So if you look at for class weight, there is dict, there is balanced, and by default it is none, right? So it has taken the default one, but you can do a balance or you can provide a dictionary with exact weights. Okay, so these are the things which you can change, and maybe someone may guide you. That's more about not applying data science, but more about knowing the maths and therefore making such changes. Okay, so once you've made a classification model, you can have a classification report and confusion matrix around it. I'm sorry, before I start with this, did I
Okay.
answer your question? Yes, please.
Yeah. And the other thing, the number of epochs also we have not defined
Yes, by
here, right?
default it has taken the number of epochs, but we can always define it. Not only we can define the number of epochs, if we are comfortable enough, we can also say if we have a big compute power, we can, and we do not have time limitation, we can say that do the iterations the uh, till there is like minimum change. So every iteration I see that I'm improving, right? My error is improving. So earlier, let's say error was 5, now it becomes 4.8, now it becomes 4.7. But if I see the improvement is in 0.000005 after 5 decimal places, I can say that keep on iterating till the improvement is less than this threshold. So I can specify the epochs, I can specify the thresholds, I can do a lot of things, and all these things are configurable.
Okay, by default, now in the model, by default, it has been setting the epochs, right?
Yes.
When
So
we hit.
depending on the model, if I do not provide anything, what did I say? I simply said that import the logistic regression model, store this in object called LR, and do a LR.fit. So as per this model, logistic regression model, whatever are the default attributes, whichever solver, so I can change the solver. So this solver warning is also coming, data set is some, there are verbose is there, but if there is, and this is a future warning for using a LFGS solver, but this is a default solver. The only thing is that on this local machine, this system which I am using, on this system, this package is not updated. So if I update the package, it will by default use the better solver, which is in the newer version of partners, newer version of scikit-learn. Okay, but these warnings will come, and these things, like penalty, it is using L2. If I want to change that, and I want a L1 penalty, or I analyze the data set and I realize that, okay, I see that there is a lot of let's say covariance. I look at the covariance matrix and I find it, okay, one thing is related with the other thing, and other thing is related with the first thing, so they are all interrelated and affecting each other. So I can also go with elastic net, a more strict regularizer. Okay, but first you have to, so those who do not understand what regularization is, what is L1, what is L2, what is elastic net, or those who do not understand what are the different solvers, what is the LFGS solver, so then they will not initially know all these things right on their first day. Okay, what will happen is, if they're able to use the API by default, and they are able to, whatever they are doing, let's say you're doing a logistic regression, you go ahead, you look at all the functions, and if, say, let's say your data scientist with whom you are working, he advises you, okay, that let's change the penalty to elastic net, and let's change the solver to this one, and let's make the class weights balanced. And then if you ask him why are we doing that, he'll tell you the reasons. He or she will tell you that I'm asking you to do so because these are the reasons. So you will not know all the maths. Someone who has studied it for, let's say, a year or 2 years at a stretch would know a lot deeper things, that why, what makes sense. But as far as applied data science is concerned, you'll be able to apply it immediately. Okay, because the default values, it will work. Your model will create some results which can be improved upon, because machine learning models are iterative in nature. So once you have a model in place, you would want a better model than that. So you make some changes in the parameters. Next time you get a better model. Do you get my point?
Yes.
Yes. So that's about machine learning. But yes, uh, we were doing it, how to do it on cloud. If we are doing this machine learning on the cloud, then yes, the same code, machine learning models code, if you see, it would have run on the cloud by now. And if you look at this code, so this is the code for machine learning models. Let's close this, training and manipulation. Okay, so sorry, notebooks. Oh, I closed it. Training. Give me a sec. Okay, machine learning models. Okay, so you see, it's the same file. The difference is here where we are reading this data store. Once you have read the data store, rest of the steps, same data set, and we are doing a regression model on top of it. We are trying to predict the price. We fit the model, we separate the x and y, we do a train test split, we fit the model, we get exactly the same values because our random number generator is, or random state is 54, same random state in both the loop. So there is no change in this file apart from simply modifying the parts where we have to read the data file. Okay, so we get the intercept, and we have exactly the same model, same intercept, same coefficients, and we have the R2 score. It is again 92.16. So there was, I was saying 92% better. We have the same. We can do all the plots which we do on local. So Azure ML supports everything. Few things there are here and there references, and few things like in the local we have to install certain things in Conda. So we have to install it here also. But everything else remains the same. These are your files for the passenger ID for the Titanic data set. We read this file. Titanic data set, we see survived, not survived, head. We handle the missing values for Titanic data set. So everything which we could do in local on the Titanic data set, we will do a logistic regression and we'll do a decision tree, and we can see both the models. This is the logistic regression model we were talking about, and logistic regression model, the same, exactly the same output as on the local. And there we see a classification report. We get the confusion matrix report. We see survived, not survived. And the decision tree model, again, we import the model sklearn import tree. We do a tree.decision tree classifier. We do a tr.fit, this tree classifier.fit x and y. These are the default parameters, criteria, Gini, depth, none, and we predict. We predict based on the tree model, and then we get the scores. So we get an accuracy of 75.37%. And we also want to plot the tree. So GraphViz model, the way I did it was, so a GraphViz, if you have to run it, you need to put it on the command prompt. So how did I do it? So you have this option of this getting into terminal. So you can just do right click, or let's say you do like this, new compute. Wait, I'm telling you how to do the terminal here.
And one more thing.
Yes.
How to know we have to use logistic regression or a decision tree classifier? Means how do we know that we have to apply this for this data set like that?
Great. So initially, if you are new to data science, you would not know. The correct answer is that anyone who knows the entire maths and who understands the data well knows. Secondly, he also does not have exact answers. So he cannot say that, okay, definitely logistic regression will work. What he'll say is, why don't you work on this data, do the exploratory analysis, do these things, show me the data. He'll see the distribution of each of the columns. He'll see which columns are important. He'll see their correlations if they are numeric. He will see various chi-square values if they are categorical. Once he looks at all these things, he suggests a few models. So he might say that, okay, try logistic regression, try support vector classifier, and try decision tree. Just the default models. And then he looks at the results. The results will guide him that, okay, maybe logistic regression is not working fine. Tree model is working fine. Support vector is not working fine. So that means maybe the data could be separated, the classes could be separated, but not in a linear way. Maybe we need a non-linear classification because he understands these algorithms. Now, if we need a non-linear classification, should I keep the default criteria as Gini or should I go to entropy? Should I do a regular decision tree or should I go to a random forest? So there are a lot of things which he knows, based on which he will guide you. Whoever you, so it's not that if you know Python and you know how to use these functions, you can solve real life business problems. If you know Python and you know how to use them, you can work with people who know how to solve problems, if I put it that way. Otherwise, in order to know how to solve real life business problems, you also need, apart from these engineering skills, you also need a lot of mathematical skills. You need a deeper understanding of these algorithms, okay, which can be important, but it takes time. So knowing all the maths of all the algorithms here would take you maybe 6 months to 1 year. So the best way to learn these things is learn them on job. Start working as a junior data scientist or a machine learning engineer who knows how to do stuff. When you know how to do stuff, when you're working under someone, you also learn on the project and you learn a lot of things. Okay, why am I doing this? Why am I doing that? You ask and you also study on your own. If you want to get deeper, you'll have to self-study. You study and your concepts improve day by day. And that's how you know a lot of things. Does that answer your question?
Yes, yes.
Okay. So at the moment, this today's class was, and we are already like 15 minutes, we've passed the time. But today's class was focused on how to do things on Azure And if you look at the Azure page, you will realize that okay, you can do everything on Azure what you can do on local, including the, let's say, if you made the tree based model, including, let's say, building graphs and plots. So if you look at this graph viz, you can see that okay, you have the complete tree built here. Okay, so you can use these graph viz and other packages. You have options of getting into terminal and running all the things which you do on regular local machine. So everything can be done. The steps are slightly different in the beginning, but please feel free to go through files. Various things have been advised in the file also, in the form of comments and all. So I hope that, and also feel free to reach me or comment on the class, ask questions. Someone may get in touch with me and tell me that these questions were asked, and I can always reply offline during the weekend if that makes sense. Is that okay?
Okay.
Plus, any pressing questions you can ask me now.
Okay.
Do you have any questions, any pressing questions which you want to get answered right now?
Yeah, hi, Agnes. It was a awesome session,
Thank you.
and I have learned a lot of things from Azure side as well as in machine learning. So, can I get it regarding and all those things? So, can I make practice from my side?
You want access to these resources? The complete links will be shared, and all those who attended this session will get the links where all the slides and everything on the, let's say, these code files, and also you will get a recording of whatever I mentioned. So you
So,
have access to all the resources.
where it will be published?
That is something. Let me just check. Paras, will you be able to assist with that?
Yeah, like the last one you're saying, or this one only?
No, this one, this one.
So it will be uploaded in the message section. It will be uploaded on a YouTube page,
Okay, and
and
they will
I guess,
be shared the links, right?
yeah, we will share the link and on the meetup page comment section also.
Okay.
So on the same meetup, like the same session they have attended, it will be there in the comment section, like maybe after 2-3 days.
Sure, sure. Please share. Then that would be very helpful and grateful for me.
Surely, you can definitely please check the message section. I've put the link there. The Kunal have already put a link there. You just
Actually,
follow that, subscribe to the channel. No, you can find old talks also, old sessions of Avinash as well.
sure, sure, sure. Thanks a lot.
You're welcome. Plus, don't worry. You can always comment, and someone would reply to the comment, and you can have the sessions there. You can watch the old sessions, and you will get the link to the resources, the code files the complete. That means you watch through the session, so you'll see how I've done. Therefore, I took you through the step of making a new account and doing everything there. Okay. So, any more questions today? Okay. Class, I'm thankful for all of you that you listened to me very patiently, and I hope I was able to resolve your doubts. And we'll look forward to seeing each other in future sessions.
Yes. Thank you.
Thank you so
Thank you.
much.
Thanks a lot.
Yeah.
Thank
Thank
you.
you. Thank you.
Thank you so much, Avinash.
Thank you, class. Thank you. Have a wonderful evening.